Hi, I am Prashant. Yes, the previous video we have seen the SLR parser, passing table, action table and go to table, and how to construct action table and go to table. And we have constructed one action table and go to table of a grammar, arithmetic expression grammar, and we executed this algorithm. Today we will see the passing action. Already in the previous video we have discussed what is the LR parser passing action. It's a shift reduce parser. It has 4 actions, and how to perform these 4 actions with a concrete example we will discuss today. Yes, here our grammar is arithmetic expression grammar, total 6 productions, and this is our passing table we have constructed. And passing algorithm we have seen. This is the passing algorithm. Generally every LR parser has the same algorithm, and it consists of an input buffer where we will store the input string, and a stack where we will store few states that a parser undergoes, and a passing algorithm, an action and a go to table, and the passing algorithm will produce the output. The only difference between different LR parsers are action table and go to table, they are different, but the passing action of LR parser is same for all categories. So today we will see how the passing action is performed on a given input. Yeah, so our grammar is ready, passing table is ready, passing action is available, stack is okay, an input buffer. Yes, our input is of the string id star id plus. So here we have 4 columns, and each column will represent the status of the different units, how the processing of string is undergone. So stack is the first column, second column will represent the input status, third column will give you the action performed by the LR parser, and fourth column will give you what is the output produced by the LR parser. So initially the stack contains state 0, and input buffer contain the input id plus id, id star id plus id ending with a dollar symbol. Yes, then look at stack top is 0 and input pointer point to id. Then first this LR parser will refer the action table. So you can see that the action table of 0 and id is S5. S5 means shift the state 5 onto the stack and advance the input pointer to the next. So next stack status is 05, where 5 is on the top of the stack, and input pointer point to star, advanced by 1. Then stack top 5 and star, 5 star, again it will refer the action table. 5 and star, it is R6. R6 is F gives ID. So the action performed with the LR parser is a reduce operation. By using the production F gives ID, that is, it is identified a handle ID in the given input. So the parser will use the production F gives ID because that handle is matching with the right side of this production. So to replace the right side by the left side F. So the parser will produce the output F gives ID. Yeah, the operation action reduce operation is first it will compute how many symbols are there in the right side. There are 1 symbol, so it will pop off the 1 symbol from the stack. Then the stack contains 0, that is on the top. The parser will refer the go to table by using 0 and F. 0 and F. Yeah, go to table 0 and F, it is 3, the state is 3. So the parser will push 3, the state 3 onto the stack. So below that 0 is there. So on the stack top you will get a new state 3, and there is no advancement of input pointer. Input pointer point to the same symbol. Yeah. Then input pointer is in star. Stack top is on 3. 3 star. Then 3 star corresponding to, it is R4. R4 indicate, yeah, F, T gives F. So the parser will perform reduce operation. T gives F. F is the handle, so replace F by T. So in the right side only one symbol. So pop off the one symbol from the stack top. So 3 will go. Then it will refer by using 0 and T in the go to table. 0 and T is 2. So the parser will push 2 onto the top of the stack. So the stack status is 0, 2, and input pointer will point to the same symbol. Then 2 star action table. 2 star is S7. S7 indicate shift the state 7 onto the top of the stack and advance the input pointer to the next. So then the stack status is 0, 2 and 7. 7 is on top. Then yeah, input pointer point to ID. Then again next step is 7 ID. 7 ID is 7 and ID is S5. Shift the state S5. So the new status is 0275. Pointer point to the next symbol plus. Then it is 5 plus. 5 plus is R6. R6 is F gives ID. So the parser will perform reduce operation using F gives ID. ID is the handle, replace ID by F. So in the right side only one symbol. Then pop off one symbol from the top of the stack. 5 will go. Then 7 will come on top. Then 7 and F. Refer the go to table using 7 and F. 7 and F is 10. So the parser will push 10 onto the stack top. Then pointer point to the same symbol plus, and it will output F gives ID as a production. Then the stack status is 10. Input pointer point to plus. So 10 plus. 10 plus is R3. R3 is T gives, yeah, R3 is T gives T star F. So it's a reduce operation. T gives T star F because the right side is T star F, that is a handle. So the parser identified T star F on the top of the stack. So that is why it is using the production T gives T star F, and it replaced T star F by T. So right side 3 symbols are there. So it pop off 3 symbols from the top of the stack. So it will pop off 10, 7 and 2. Then the stack top is 0. Then 0 and T. Go to table 0 and T. 0 and T is 2. So the the LR parser will push 2 onto the top of the stack. Then current status of the stack is 0, 2. And input pointer point to same symbol, and it will produce output as T gives T star F. Then 2 plus is R2. R2 is E gives T. So the reduction is using E gives T. So one symbol it will pop off. So it will come 0, and 0 and E is 1. If you refer the go to table, you will get 0 and E, you will get 1. Then the parser will push 1 onto the top of the stack. 0, 1 will get after that. Input pointer point to the same symbol. Yeah. Then and produce an output of E gives T. The next thing is stack top is 1. Input pointer point to plus. Then 1 plus is S6. So it shifts the state 6 onto the stack top. Then you will get 0, 1, 6. The input pointer point to the next symbol. So 6 and ID is a shift 6. again it shifts the state 6 onto the stack top. So the status is 0, 1, 6, 5. 5 is on top. Then advance to the next symbol. Next symbol is dollar. Then you can see that 5 and dollar. 5 and dollar is a reduction operation because action table contain 6 S6. S6 is F gives ID. So reduce by using F gives ID. So one symbol, because right side one symbol, so pop off one symbol, then you will get 6, and 6 and F is 6 and F is 3. So the parser will push 3 onto the top of the stack. Yeah, fine. Then input pointer point to the same symbol. Then 3 and dollar is again a reduction operation using T gives F. Then one symbol it will replace, 3 will go out, then 6 will come, and 6 and T is 9. So then the parser will pop off 3 and push 9 onto the top of the stack. Then input pointer point to the same. Then 9 and dollar is E gives E plus T. 9 dollar, you can see that 9 and dollar is R1, where our R1 is E gives E plus T. So 3 symbols in the right side. So 3 symbols popped up from the stack, then you will get 0, and 0 and E is 1. Then LR parser will push 1 onto the top of the stack. So this is the stack top and will produce an output of E is E plus T. Then stack top is 1, input pointer point to the same symbol dollar, then $1 is accept. So you will get an accept from action table. So the parser will understand that it's successfully finished the parsing operation. Then the parser will terminate with the successful status. Yeah, so that is what this is the total parsing operation of a given string ID star ID plus ID. Now look at here how the parse tree is constructed. It will start from anywhere ID and F gives ID. So you can see here first F gives ID here F gives ID, then F replaced by T, next one F replaced by T, then it will go to here F gives ID, yes, third one F gives ID, so it will replace this one, then both T and F is ready, so T star F we can perform, so this one by T, so you can see here, yeah, then next is T is ready, then it replace T by E, yeah, this one, then it will go to this one, this side, right side, and F gives ID will come, then F is ready, then it will replace F by T, then yeah, E is ready and T is ready, then E plus T can perform, so it replaces E plus T by E, so it reaches the root. So in the past, if you perform post order traversal or depth first search, you will get the node which generated by the parse tree. And in the rightmost derivation of the given string is E gives E plus T, and E plus T derive E plus F, because T is the rightmost non-terminal replaced by F. Then E plus F, again E plus ID will come because F is replaced by ID. Then T plus ID, and T is the rightmost by T star F plus ID. Then F is rightmost, T star ID plus ID. Then F, because T is the rightmost, F star ID plus ID, and ID star ID plus ID. So what this SLR parser did is, it's starting from this string and it produced this one, this sentential form. Then from this one it produced this sentential form. Then this sentential form it produced the previous of the right sentential form. From this one, just previous of the right sentential form, just a previous of the right sentential form, and keep on producing this right sentential form just a previous of the existing, then finally it reaches root. So this is the called right sentential form generation in reverse order. So that is what a SLR parser is doing. Not only SLR parser, every LR parser is doing. So thank you for watching this video. So we will come up with a new video with a new parser, LR parser. So thank you for watching.